Now we actually have somebody here from Google who flew over from Mountain View, California. So she's as jack-led as I am. And it's Pavithra Vijay. And she's going to talk to us about Keras and actually making machine learning easier for you by using that system. So without further ado, go ahead.
Thank you. Good morning, everyone. As you mentioned, my name is Pavithra. I work for the Keras and Tensorflow team at Google. Today, I'm going to be talking about Keras, its APIs, and how it makes the barrier to entry much lower to start using state-of-the-art deep learning models. So here's the talk outline. I want to start by focusing on what the problem is that we're trying to solve. And then we'll dive into the Keras APIs, and I'll talk a little bit about the integration of Keras with TensorFlow. So to start with, all of us have seen the incredible progress that machine learning has made in the last decade. We have gone from nearly unusable image and speech recognition to near human accuracy. We have machines which could not even play Go with a serious Go player to machines that beat the world champion today. This is similar to what happened with internet few decades ago. Internet revolutionized the entire world, every industry in the world, and that's what's happening with AI today. But what we see is that, as of today, it's just an accessory to our day-to-day processes. For example, you may use your phone to look for product recommendations, or you may use your AI assistant to look up for birthday pictures. But it's still not fundamental to our everyday activities. And we have a long way to get there. And what we want is for libraries like Keras to help make that process much faster. So the idea is that deep learning as a concept is very simple, but the kind of problems that it can solve is complex. And a good library, good API should reflect the ideas and not the complexity of the problems. So what is Keras? Keras is high-level neural networks API. It's important to understand that it's not an end-to-end framework like TensorFlow or Theano. It is a language or a front end to one of these frameworks. And just like any other language, Keras has different flavors. There is the multi-backend Keras, and many of you may be familiar with that already. It's the GitHub project. And with that, you can plug and play with different types of backend frameworks, such as TensorFlow, Theano, CNTK, MXNet, and so on. And there is a flavor of Keras within TensorFlow, which is called the tf.keras module. It is the high-level API for TensorFlow. And there are other versions of Keras, like Keras for JavaScript, Keras for JVM, and so on. And with all these different flavors of Keras, you can leverage the various hardware platforms that comes with the framework that you're working with. So you can run your model on CPU, GPU, cluster of CPUs, cluster of GPUs, and today even on TPUs. So why should you use Keras? As I just mentioned a couple slides back, Keras provides you with a very easy set of APIs. Even somebody who has just begun working with Python, who has very minimal scripting abilities, can develop deep learning models. You do not have to be an expert. And you can quickly prototype models in that. For example, if you go to competitions like Kaggle, you will see a lot of the code written is using Keras, and that's because it's very easy to experiment, start off and write a bunch of models and see which works best for your problem. And this does not mean you lose any flexibility in that. Irrespective of which framework you're using, you can leverage the strength of the framework and develop complex models such as GANs or neural style transfer models, and so on. So who writes Keras? The external GitHub project, there are about 754 contributors as of today. And I work for the Keras team at Google, which is about 5 people, and it's steadily growing. And this includes François Chollet, who is the author of Keras. And there is a team at Amazon, which is around 3 to 5 people who are focusing on the performance of Keras with MXNet. And there is a team in NVIDIA and Microsoft as well. Brief history. So Keras was started about 3.5, almost 4 years ago. And over the years, we have added support for a number of backends. And earlier this year, Keras was announced as the high-level API of TensorFlow. And the graph here is actually outdated. Today, there are about 300,000 users for Keras. And here is the small list of sample of companies which use the APIs. So to the fun part, how to use Keras. There are 3 main categories of APIs that Keras provides. One for model building, then second for training, evaluation, and inference, and the third for saving and serialization to be able to reuse your models. So as I mentioned before, we want the APIs to be very simple, which means that users who are using these APIs should have to remember very few concepts. So there are 2 main data structures in Keras, layers and models. And you can think of layer as just a data processing unit. It takes a bunch of input, it performs some transformation on them, and returns a bunch of outputs. And a model is basically how you put these layers together. So we will see what the APIs that Keras provides for each of these. So starting with model building, there are 3 different ways you can create a model in Keras. And let's say you are a beginner to machine learning, and you would just want to put together a couple of layers in a linear fashion. And this can be accomplished using the Sequential Model API. And this shockingly covers 70% of the models that users want to write. This is literally linear stack of layers. And for anything more complex, like a non-linear model, like multi-input, multi-output, or a shared layer model, we use the functional API. And these 2 cover almost all use cases. And this year, we also added support for subclassing models. This is for very niche use cases where you may want to put together a bunch of layers or a model and package it and reuse it, and use cases like that. So here is how you would create a model using the Sequential API. As you can see, it's just a few lines of code. And so you have the Keras library, and you create an instance of the Sequential model. And all you have to do is call add on the model and add the stack of layers that you want on it. In this case, this is an example of a multi-class classification problem. Hence, the last layer is a fully connected layer with the number of classes. In this case, it is 10 as the output, and the activation function as softmax. So if you want to do a binary class classification, the number of units would be 1 instead of 10, and the activation that you have here would be a sigmoid function. So before we go into the other model types, the way you train your model, save it, is the same for irrespective of whether you use the sequential or the functional API. So we'd see what the APIs are for training and saving. For those of you who are not familiar, when you have a machine learning model, you've defined the model architecture, the next thing you do is to train your model. And by that, I mean that you give your model a set of inputs, and you look at the predictions and compare this with the expected output. You see how far off it is, and you measure the error there is in this process. And this error information is measured using what is called the loss function. And once you have this, you go over back to your model, update your state of the model, which is the weights on the model, using the optimizer. And you repeat this process until you reach a point where your model cannot learn anymore. And so the 2 main things that are required for training are your loss function on your optimizer. And you can specify these to a model in Keras using the compile API. And in addition, you may add 0 or more metrics that you want to compute on the model. And as you can see here, Keras comes with a lot of built-in metrics and loss functions and optimizers. And you can specify it in a number of ways, as simple as a string shown here, and You can also use the built-in function to update any of the parameters if you want to. And if you want to create your own custom loss and metric functions, which do not have a standard signature, that is, which does not just operate on labels and predictions, you can do that. And you can use the add loss and add metric APIs to add those to the model. So now we have the model architecture, and then with the compile API, you have specified what the training parameters, that is the loss and the optimizer on the model. And the next thing to do is to actually train your model, and this you do with the fit API. This is the last line here, and that's it. It's just one single line that you need to write for training. And the X and Y here are the labels and predictions. And with that, you specify the number of epochs and the batch size that you want to train for. And the fit API returns the history of training. That is, like for each epoch, you can get what the loss value and the metric values were. And with that, you can see how your model improved over the time. Some information on like what inputs you can pass for training. You can pass a NumPy array just like any scikit-learn APIs. And in addition to that, with the tf.keras, the TensorFlow Keras that I was mentioning earlier, you can also pass what is called the tf.data dataset instance. You can think of a dataset as a module which encapsulates just a collection of data and how the data is transformed, that is, how the data is delivered in the distributed settings. So in TensorFlow Keras, we also support passing dataset as input. So after training, how do you validate your data? So there are three ways you could do that. The first option that is shown here is you could do validation as part of training, and you do that by specifying the validation split parameter. So basically what you're saying is take a portion of my training data and use that for validation during every epoch. So when you train, you can see your loss and metric values for the training data as well as for the validation data. And another way is to specify a separate validation data, which is not part of the training data. And you do that by using the validation data parameter. And if you want to do validation after you've done the training, you can do that using the evaluate API. And the parameters that you pass to it are, again, very similar to what you did with the fit API. And now to predict. This is similar as well. You just use a predict API with the labels that you want to do inference for, and that's it. So with just these three APIs, we've gone from defining model architecture to training, validation, and inference. And as mentioned before, irrespective of what type of model you're using, these APIs remain the same. Like how you use them is the same. On to saving. Let's say you're an absolute beginner to machine learning. The first thing that you want to do is probably pick up a model that somebody has already written and play around with it and see what the predictions are. Like, that's the fun part, right? Like, I remember picking an inception model, passing it some images and seeing whether it predicts the label correctly. And this is exactly what saving is needed for. Like, we want to be able to save model architectures, complex model architectures that were created, and also model weights. And in Keras, you can do that using the save API. And in the TensorFlow Keras, you can also save in the TensorFlow checkpoint format. And once you've saved the model, like the save API here saves the model architecture as well as the weights. So you can just load onto another model instance and use it as you were using the model before. And you could just save the model weights using the save weights API and load using the load weights API. So you could create one model instance and if have another model with the same architecture, you could load the weights onto that and continue training on that with a different data set and compare these two models and so on. And these are the APIs for saving just the model architectures in human readable formats such as JSON and YAML. So now we've seen the different APIs for training and for saving. Now back to the second model type. Like we've seen the sequential type, and now this is a functional API. As mentioned before, functional API is used for scenarios where you have a nonlinear graph. So this example is of a multi-input, multi-output graph. So this particular example is you can imagine, like here, let's say we have a tweet sent as an input to your model, and the auxiliary input in this case is some additional information such as time of the tweet. And you pass both that information to the model, and then you pass it down set of data processing units, and then finally you get predictions such as like how many retweets there were for a particular tweet. And the auxiliary output here is just an additional loss function. And like when you have very deep models, sometimes you use loss functions earlier in the model to reduce overfitting. So for such models, you'll use the functional API. Here is another example of functional API, and in this case, we are sharing a layer. So the use case here is that you have a couple of tweets, and what you want to do is to compare the tweets and see if they are from the same author. And so because like the tweets are the same information, we are going to encode them similarly. Basically, we pass it through the same data processing unit. So you pass it through a single layer and get the encoded output corresponding to each tweet. So one thing to note here is that here we're using the layers that we have created as functions. So in Keras, every layer and model can be used as a function. This is what happens behind the scenes with the sequential model as well. So when you created a model and just called add on it and added a bunch of layers, what was happening behind the scenes is the input was just cascaded down through layers. So similarly here, you're taking the input, passing it through the first layer, getting the encoded output, and then you're passing it to the next layer and the final layer, and you're getting the final output, and so on. So how you create the functional model is using the Keras.model API, and you pass it the set of inputs and outputs. And the way you compile to specify the training parameters and use the fit API is the same. And the one difference here is that like if you have multiple inputs or multiple outputs, you'll have to specify or provide that many inputs or outputs to the fit API. Quick note on model subclassing. As mentioned before, like most of the use cases should be able to be solved using the functional and the sequential APIs. And this is a use case for using model subclassing. If you want to package a set of layers and reuse them, or you want to dynamically debug model in the call function, use cases like that. So you just subclass the Keras model API and create the set of layers that you want in the init function. And in call, you specify the model architecture. You create the subclass model instance and use it like any other model. You can also use it as part of a bigger model that you're creating, and so on. So a little bit about Keras and TensorFlow integration. So as there are three things that I want to highlight as part of integration. So these are three main features which were added to TensorFlow this year, one of which is tf.data module. As I mentioned before, the tf.data module is basically used to define the input pipeline for your model, and it's a collection of data and how you transform the data put together in a module. The other thing is eager execution. This year we added support for writing ops imperatively in TensorFlow, and the TF Keras API, which I've already talked about. So why this is important is that what we've done with tf.keras is we've taken the multi-backend Keras and we have optimized it for TensorFlow, in that like it adds support for TensorFlow specific features such as the tf.dataset is supported with every Keras API, and also you have support for the TensorFlow distribution strategy. You can run your Keras models on GPUs, TPUs, and the Keras API support eager execution with TensorFlow. For those of you who are familiar, TensorFlow also has the other high-level API called Estimator. So you can take a Keras model, convert that into an Estimator API, and you can use like Estimator features such as serving, and other such functionalities that Estimator provides. So a little bit about eager execution. So for those of you who didn't know about like earlier versions of TensorFlow, it only supported creating models as a graph. In that, you create a graph of ops, you compile it, which optimizes this graph, and then you run, which means you cannot see how your input is passed through the graph. You cannot debug this information. And this is exactly what you can do with eager execution. And this is very powerful as a developer when you can see how your input is being processed. And a couple of examples of Keras and eager execution. Here we have created a functional model as before with the inputs and the outputs. And here to the model, you can directly pass a value array and get predictions from it. And you can also use the other training APIs as mentioned before, and you can debug through them. Here's another example of how you can use eager execution to write imperative custom layers. So here, as you can see, like you define the call function for your custom layer, and you can actually print your inputs to the layer, and you can debug through the conditionals and loops. So here is an example of how you can use the TensorFlow distribution strategy with the TF Keras APIs. So TensorFlow comes with a number of distribution strategies, and one of that is a mirrored strategy. So what you need to do is create an instance of the mirrored strategy with a set of devices that you want to run your model on, and then you create your Keras model, and you compile the model within a strategy scope. And as you can see, the code here for creating the model, compiling, and for training is the same as before. The only difference is we are doing this in the scope of a distribution strategy, and your model will run seamlessly in the devices provided. So a little bit about the timeline of recent and future changes that we're making. As I mentioned before, like the tf.keras was announced as a high-level API earlier this year, and we are making a lot of changes to tightly integrate and optimize the tf.keras module for TensorFlow. We have integrated the metrics and losses modules between the two, and with the new TF 2.0 release, which is coming up in early next year, we are adding extended support for distribution strategies, and also we are like revising the TPU distribution strategy support that exists already. So that's it from me. I hope this talk was useful. For those of you who are already familiar with Keras, I hope there was some new information. And for those of you who are not, like, I hope you found the APIs very simple. Yeah. Thank you very much.
Aww. Well, thanks very much. We have a few questions. And there's actually one, not a question, just a comment. Thank you for this great talk. Nice high-level introduction, yet driving me into some technical details. No marketing speak. Isn't that good? That's the kind of stuff we like as a speaker.
That's true. It's the fun stuff.
This seems like wasting our time, but these things are super important. Speaking is not easy to do. We put a lot of effort and work in, and sometimes a thank you like that out of the blue really makes our day, because we're people too. Some of us, most of us. Are there any plans to implement mechanisms which would enhance the explainability of complex models?
The first thing that we're doing is actually cleaning up a lot of our like fundamental layer and model APIs that we have, so that it's easier, like for you when you read the code, to understand. And I believe like we have already started with that process, and once that is done, it will help write cleaner models. And for those of you who are familiar with the code already, what I'm talking about is like Keras has a base layer implementation, which is the mother of all layers and models. And we are starting with cleaning up the base layer implementation and requiring as little as possible for users who have to implement custom layers and custom models. And another thing here is that we are also tightly integrating with the eager execution, as I mentioned before, so that very little has to change when you're writing a model between like graph and eager execution. Ideally, nothing has to change. So that again hopefully will help with when you're writing complex models, like you can use like eager execution for debugging through your model, making it easier when developing.
Cool. Most neural networks work as black boxes. Do you have any tools or know any tricks to understand the model's reasoning in Keras?
That's a great question.
That's why we picked it.
Sorry?
That's why we picked it.
So I'm not sure if we have anything specifically for model reasoning. I think there are a number of projects which are like open source project, which is outside of Keras, like which others are using Keras to develop. Like maybe I don't remember the names at the top of my head. Like I can maybe look that up. Like if you can shoot me an email, I can get back to you on that. But with Keras itself, we don't have anything specific to understand model reasoning. It's just like any neural network API. It's very difficult to exactly understand what's going on in that like data processing units.
Something to work on, perhaps. There's lots of requests to share the slides and the demos, so that would be something that is possible?
Yes, absolutely. I can provide link to these slides.
Just tweet them out to the, with the hashtag of the event. That's what I did. And nobody found them. But anyways. Yep. Which are the most common prediction models used? What do people use it for?
I wouldn't know the answer to this, honestly speaking. Let me think.
You can always say skip to the next one if you don't know the answer. It's all good.
No. So basically, from word of mouth, I have heard a lot of people use ResNet. Other than that, like I'm not familiar what would be like most common prediction model. Yes.
A lot of times ResNet is also used for just like benchmarking, and like it's a great example for that.
Exactly.
And of course OpenCV is another one, facial detection kind of things.
Right.
Yeah. So what does Keras have GPU multi-thread support, for example, when utilizing TensorFlow? And there was also another question that the CPU and GPU gets done automatically if there's a chance to switch that to TPU in the future.
So to answer the first question, that is, yes, Keras has GPU multi-thread support when using with TensorFlow. This was in one of the slides that I showed. You could create an instance of the TensorFlow distribution strategy and just create your Keras model within that scope, and it will work with like multi-GPU or CPU, GPU, whatever combination that you have. The other question, sorry, can you repeat?
It's automatically switching between GPU and CPU, and if there's any option to have TPU support out of the box as well.
So the TPU support today works slightly differently than the GPU support, but we are, as we speak, we are actually integrating, and so that you can do that. And this, I hope, will be part of the TensorFlow 2.0 release.
Excellent. I don't want to do the PyTorch and fast AI thing. It's always like the comparison questions are always weird to answer. Why did you kick out F1 score metrics?
What are F1 score metrics?
OK, so we switch to the next one. Are you planning to support sparse matrices as inputs?
Yes, we are. Yeah, you can already pass sparse matrices to the APIs if I'm not wrong. I haven't tried it in a while, so I wouldn't be 100% sure about that. But yeah.
Why should I choose Keras instead of TensorFlow or CNTK?
because TensorFlow adopted Keras as the high-level API for its simplicity, and that's exactly why you should use it. It's very easy to start working with deep learning using Keras APIs. Even if you're like a research user, it is going to make your life just as easy. And and Keras supports both TensorFlow and CNTK as a backend. So.
Excellent. I think we're out of time and we're out of questions. So thank you so much. Are you going to be around for the day if people have more questions?
Yes, I'll be around. Please feel free to reach out to me or even email me. You can reach me at PSV, P as in Paul, S as in Sam, B as in Victor @google.com if you have any more questions. Thank you.
Well, that was easy to remember. So thank you very much, and it was a great talk.